All right, welcome to the fifth video on this bootcamp. We're going to be going over what is blockchain and how does it work. This is a simple introduction to the revolution technology that powers all of the cryptocurrency, and it's going to transform how we think about our digital trust. So think of it as like a digital ledger. For example, we have traditional ledgers in the banking system. Banks keep them in a centralized database. You trust them to maintain your account balances and transaction histories. There's a single point of control. It requires trust in the institution and it can be altered and manipulated. A blockchain ledger. It is a shared, transparent record book that everybody can see, but nobody can cheat. Every transaction is permanently recorded. It is distributed across the network, transparent and verifiable, and tamper-proof by design. So I'm going to go ahead and I'm going to show you an example of what this might look like. It's pretty bright. So this is called SolScan, and this is going to, I just pulled up a random address right here. You can see that this guy, here's his wallet address. He has a total of $12,000 in it. He is holding Z Combinator, he's holding Tesla stock, Nvidia stock, Circle stock, Apple stock. You can see what he's holding and you can see all his transactions. You can see exactly where he's sending money, you can see where he's getting money. So the blockchain is basically like a decentralized banking system. Again, there's nobody who controls the blockchain. Um, anyway, the power of decentralization. Like I was saying, there's no single authority. Instead of one bank controlling everything, thousands of computer nodes work together to maintain the system. It is always available. This network never sleeps. It's 24/7. Again, like I talked about in the last episodes, you have to wait for your bank to send money. It is 24/7, instant. There's global access anywhere in the world. Anyone with internet can participate, and that removes the geographical barriers of sending money. So, all right, understanding blocks. Think of a block as a container that holds transaction data. Each block contains the transaction data, the details of who sent what to who, including the amount and the smart contract signature. It includes a timestamp. It's going to show what time that money was being sent, and a unique hash. It's basically a digital fingerprint that uniquely identifies that specific block of data. Blocks are linked together through cryptographic hashes, creating an unbreakable chain where each block references that one before it. So block 1 contains hash of previous block plus new transactions. Block 2 references block 1's hash, making a tampering detectable. Block 3 continues with the chain, each block securing the ones before. If someone tries to change an old transaction, it would break the chain and alert the entire network instantly. How transactions work. Transaction request. Just say Alice wants to send money to Bob. She creates a transaction with her digital signature. Number 2, the transaction is sent out to thousands of computers in the blockchain network. And then there is a validation check. The network computers verify Alice has enough funds and her signature is authentic. Number 4, it's grouped into a block. The valid transaction are collected together with the others in a new block and then added onto chain. Network nodes, the guardians. What are nodes? Nodes are individual computers that maintain a complete copy of the blockchain and validate new transactions. So your computer is most likely a node. All the computers using a blockchain or blockchain technology could be a node for all these transactions. So it stores the entire transaction history, verify incoming transactions. They communicate with other nodes and they enforce network rules. Strength in numbers. There's thousands of nodes worldwide. The network becomes very resilient and secure. Oh, these are big words. These are big words. The beauty of immutability. Once data is added to the blockchain, it becomes virtually impossible for it to be erased. There is a cryptographic protection. Each block hash depends on all previous blocks, like we went over in the last slides. There's a network consensus. Thousands of nodes must agree on a change. A single bad actor cannot manipulate the system. Security that never sleeps. Multiple layers of protection. Cryptographic hashing. This is advanced mathematics to protect data integrity. There is some myths going on online that computers will be able to solve these mathematical equations, and that is simply not true. Our best quantum computing system cannot solve these mathematics. There's distributed architecture, no single point of failure across the network. Again, those nodes, transparency. Like I showed you on that soul scan, all the transactions are publicly visible and verifiable. And the majority agreement needed for change. So, is the blockchain better than our banking system today? Absolutely. Why? It is way more secure than a traditional ledger or database. It operates 24/7 without human oversight. And it creates trust because everything is recorded online and it is impossible to fake transactions or fake money moving. So that's going to be it for this episode. Tell me how these videos are coming along, if you're liking these videos, if they're boring, if you want me to change it up. I'm trying to get as much fundamental information I can in the shortest amount of time. So I'll see you in the next one.